Hi, my name is Meeta Kumar. The module I present now deals with production concepts. Production is the process of transformation of physical inputs into physical output. It is an economic process that uses resources to create a commodity that is suitable for exchange. Resources such as land, labor, capital, entrepreneurship are called factor inputs or factors of production. Land typically includes all natural resources. Capital includes all man-made resources that are used in production, machines, tools, factories, etc. Entrepreneurship or enterprise is what brings various factors together to organize production. In other words, production represents the process through which different factor inputs combine to produce goods and services which are used to satisfy human wants. A production function is defined as the mathematical or algebraic expression which represents the functional and technical relationship between physical inputs used in the production process and the physical output produced. It can be mathematically expressed as Q equals F of L and K, where Q is the output produced in the production process, L is the labor employed as a variable factor, and K is the capital employed. A production function represents the maximum production level that can be achieved from a given level of employment of inputs in the production process and at a given level of technology. A firm's output depends upon the labor employed and the capital used in production given technology. Let us assume a firm wants to increase its output. It can do so only by increasing the inputs it uses. But it cannot always change quantities of labor and capital in the same proportions. Generally, labor units can be employed at short notice easily, but it takes more time to install machinery and equipment. That is, it takes more time to install capital. This means that certain factors remain fixed or constant, while others can be changed more readily during the production process. Suppose a firm is manufacturing wooden furniture with the help of two inputs, capital and labor. If it produces 20 tables by using 10 units of capital and 5 units of labor, then the relationship between physical inputs, that's 10 units of capital and 5 units of labor, and the output, which is 20 tables, is called a production function. Note that this is the technology used that determines the maximum level of output which can be produced by using different combinations of inputs. With advances in technology, more can be produced with smaller amounts of inputs. We then have a new production function. The main features of a production function are as follows. 1. It's a physical technical relation. A production function signifies the functional and technical relationship between inputs and output. It is purely a technical relation and not an economic relation. It has nothing to do with the money value of output produced or the prices of factors of production used. Second, it is determined by technology. The quantity of factors of production to be employed and the output which will be produced, as well as the manner in which the inputs are combined, depend on the state of technology. The state of technological knowledge and managerial ability of the firm is treated as given for a production function. And third, the relationship between output produced and inputs used in the production process depends on the economic time period under study. The variability of inputs used in the production process depends on the time. Some inputs cannot be changed in the short run, that is, some inputs are fixed, and hence output can only be changed by changing the units of other inputs, which is the variable inputs. Changes in the total output by changing all inputs are possible only in the long run, whereas changes in the total output by varying the amount of a single input may be possible even in the short run. On this basis, it is common to discuss production functions over the short run and long run. The short run is a period in which at least one factor will remain fixed and not change. Production can thus only be increased by using more of the variable inputs. So, in the short run, production takes place with the help of a fixed factor and a variable factor. The short run production function may be described as Q is equal to f of L and K, where L is typically a variable factor and K is usually the constant factor. Fixed factors are those inputs which remain fixed and do not change with the level of output. They remain constant in the short run. Land, machinery, equipment, etc. are typically assumed to be fixed in the short run. Variable factors are those inputs which can be changed easily in the short run and cause a change in the level of production. With every additional unit of input used, there will be an increase in the level of production. So, let us take an example to understand fixed inputs and variable inputs in the short run. Suppose a manufacturer produces socks in his factory. The land he has is 2000 square feet and machinery is installed. Now, machinery and land can be considered as fixed factors, as the producer is not going to change those factors every time he produces more units of socks. Along with these fixed factors, production requires other factors such as labor, raw material, electricity, fuel, etc. These are called variable factors. In order to increase production, the manufacturer will have to increase the use of labor and other variable factors. In the short run, total production can increase only with the increase of the variable factor. How does output change when the variable factor is increased? This depends on returns to factor. Three phases under returns to factor are typically distinguishable. Increasing returns to factor exists when an increase in output is more than proportionate to the increase in input. In other words, if input doubles, output more than doubles. Diminishing returns to factor are said to exist when the increase in output is less than proportionate to the increase in input. In this case, if input doubles, output will less than double. Negative returns to factor exist when the increase in input actually causes the output to fall. We shall explain why these returns to factor exist in the next module. We now turn to the long run production function. In the long run, output can be changed by changing all the factors of production. A long run production function is also described as Q equals f of Lk. In this case, both L and K are variable factors. As all the factor inputs are variable in the long run, the ratio between various inputs can remain the same at different levels of output. Increasing all inputs in the same proportion is called scaling up the inputs. The change in output that results from a scaling up of inputs is described under returns to scale. Three types of returns to scale operate, and these are: first, increasing returns to scale. In this case, the increase in output is more than proportionate to the increase in inputs. So, for example, if all inputs are doubled, under increasing returns to scale, output more than doubles. Constant returns to scale are said to exist when an increase in output is exactly proportionate to the increase in inputs. In this case, if all inputs are doubled, output also exactly doubles. Diminishing returns to scale. This is the case when increase in output is actually less proportionate to the increase in inputs. If all inputs are doubled, output also increases, but it less than doubles. We now turn to three concepts related to production, and these are total product, average product, and the marginal product. Total product is sometimes also called the total physical product and is defined as the total amount of output produced by a firm using a particular input during a specific period of time. It means total quantity of commodity produced at a particular level of employment of a certain factor, say labor, keeping all other factor inputs constant. Alternatively, it signifies the relationship between variable input and output when all other inputs are held constant. Average physical product is the output per unit of a variable factor. It is obtained by dividing the total physical product by the number of units of the variable factor used. If 5 units of a variable factor, say labor, produce 50 socks, then the average product will be equal to 50 divided by 5, and that equals 10 socks. It has generally been observed that when more units of a variable factor are employed for producing a commodity, the tendency of the average product is first to increase and then to fall. Average product is also called the average physical product. The third concept is that of marginal physical product, and this is the addition to total physical product or output when an additional unit of the variable factor is employed. Marginal product measures extra output per incremental unit of input, holding all other inputs constant. Thus, additional output added by the use of an additional unit of input, say labor, is called marginal product of labor. For instance, with a given amount of capital, if 10 laborers make 50 socks and 11 laborers make 54 socks, then the marginal physical product of labor is said to be equal to 4 socks, which is 54 minus 50. This is the addition to the total product by employing the 11th laborer. Notice that the total physical product is the sum of all the marginal physical products of the preceding units of the variable factor employed. Notice also that the total physical product is the multiple product of the average physical product and the number of units of the variable factor employed. Now for some general information about production curves. The total product curve is actually a graphical representation of the changes in the total product as the variable input is changed. It measures the total product on the vertical axis and the amount of factor input on the horizontal axis. Similarly, the average physical product curve and the marginal physical product curve are graphical representations of the changes in APP and the MPP as the variable factors change. Both curves, the average physical product curve and the marginal physical product curve, are ultimately based on the total physical product curve. The relationship between the two is that the marginal physical product actually measures the rate of change of output when an additional unit of the variable factor is employed, keeping the fixed factors constant. While the average physical product measures the average amount of output from each unit of the variable factor used. It is the marginal physical product that acts as a driver for the average physical product, since the rate of change in marginal physical product will directly affect the average physical product. If the marginal physical product is more than the average physical product, it will pull up the APP. If it is less than the average physical product, then the APP falls. When the average physical product is maximum, the average physical product and the marginal physical product are equal. The same information can be represented in a production schedule. A production schedule is a table that describes the changes in the total physical product, the average physical product and the marginal physical product as the amount of the input used changes. And the diagrammatic representations of these variables give us the TPP curve, the APP curve and the MPP curve, which are shown in the diagram on the screen. We can discuss the relationship between TP and MP. On the x-axis, we have taken the units of the variable factor, and on the y-axis, we have taken the production curves as TPP and MPP. With the employment of the first unit of the variable factor, keeping land fixed, TPP is increasing at an increasing rate till the point P. Beyond P, TPP still increases, but it increases at a decreasing rate. The point P is therefore called a point of inflection. That is, it indicates the point at which the TP curve changes shape from an increasing rate of increase to a decreasing rate of increase. The marginal physical product increases till P, where it reaches its maximum. After the employment of the second unit, the TPP is increasing at a diminishing rate. Notice that at this level, the marginal physical product starts falling. Although the marginal physical product continues to fall till 5 units of the variable factor are used, it is still positive. And because it is positive, the TPP continues to increase, but it increases at a diminishing rate. When the TPP reaches its maximum, that is at the point M, the marginal physical product becomes 0, as shown in the point N, that is at the 5th unit of labor. Further employment of labor beyond the 5th unit, the TPP starts falling. So, after M, that is from the 6th unit of the variable factor onwards, the marginal physical product becomes negative. We can show the relationship between the average product and the marginal product by this diagram on your screen. On the x-axis, we have taken the units of variable factor as before, and on the y-axis we have MP and AP. As long as MP is more than AP, the average product increases, and this happens up to the second unit of labor. Notice that AP continues to rise even when MP is falling till the third unit, as MP is more than the AP till the third unit, and the MP curve lies above the AP curve. When MP is equal to AP, AP is at its maximum at the third unit of the variable factor. When MP is less than AP, AP falls, that is, after the third unit of the variable factor. In fact, after the third unit of the variable factor, both AP and MP fall, but the fall in MP is faster than the fall in AP. So, to conclude, in this module, we have looked at the concept of production, and we have looked at the difference between the short run and the long run in economics. We have also defined concepts of total product, average product, and marginal product of a factor. In the next module, we will examine the relationship between these products in a little more detail. Thank you.